You're listening to an African Elements top news story for July 30th, 2025. Please visit our website at africanelements.org for more daily news. Climate change, marked by increasing heat waves and floods, threatens global agriculture and food security. Predictive models indicate a grim future for agriculture without adaptive strategies to enhance crop resilience. The average global temperature is projected to be 1.5 degrees Celsius warmer between 2030 and 2052, and more than 3 to 4 degrees C warmer by 2100 at the current emission rate. This increase could lead to a 15 to 35% decrease in crop yields in Africa and Asia, and a 25 to 35% decrease in the Middle East. Climate is the most crucial factor influencing crop production, threatening the sustainability of food systems. Extreme weather events detrimentally impact crops by affecting their physiology, growth, and yield. High temperatures negatively affect vegetative growth and reproductive processes in crops like tomatoes, leading to losses in yield and quality. Heat stress can be evaluated by examining parameters such as stomatal conductance, net photosynthetic rate, and fruit yield. Adaptive strategies in agriculture include methods and technologies to help crops cope with climate change and environmental stressors. These strategies encompass a range of approaches aimed at improving plant resilience and productivity. The application of microbial biostimulants is a long-term strategy for improving plant productivity, even under climate change-associated stresses. Beneficial fungi, yeasts, and bacteria can boost growth, yield, nutrition, and stress tolerance in plants. Plant growth-promoting rhizobacteria, PGPR, are beneficial bacteria that mitigate the negative effects of abiotic stresses like drought and salt stress. Microbial mitigation strategies are being explored to increase crop production, particularly in the context of heat stress. Biostimulants and microbial inoculants improve crop vigor, yield, and tolerance to abiotic stresses. They offer sustainable ways to enhance agricultural productivity in the face of climate change. PGPR can promote plant growth by supplying nutrients and regulating phytohormone levels. They help plants cope with abiotic stresses exacerbated by climate change. Climate change intensifies extreme weather events, significantly impacting agricultural productivity. Droughts and soil salinity reduce plant growth and productivity, especially in arid regions. Climate change exacerbates the effects of abiotic stresses on plant growth. Abiotic stresses impact plant responses, leading to altered metabolic pathways and reduced growth rates, resulting in significant crop yield losses. Plants are exposed to unpredictable climatic changes, causing drastic losses in agricultural production. The omics approach has advanced the understanding of how biostimulants act on plants at cellular levels. This scientific approach allows researchers to study the entire set of genes, proteins, or metabolites within an organism. Understanding these mechanisms helps design effective biostimulants and crop management strategies. Biostimulants can act as messengers in signal transduction, aiding future crop management strategies under changing climate conditions. Evaluating heat stress involves assessing stomatal conductance, net photosynthetic rate, and reproductive success indicators. These physiological parameters are vital for assessing crop health and developing targeted interventions. The impacts of climate change on agriculture extend beyond crop yields, affecting food availability, access, and affordability. When crops fail due to extreme weather, food supply decreases, leading to higher prices. This disproportionately affects vulnerable populations, including many in the African diaspora. The University of Arkansas System Division of Agriculture estimated crop-related flooding damage in Arkansas in 2025 to be $78.9 million. According to the American Farm Bureau Federation, in 2024, farmers lost $20.3 billion to weather disasters. The economic consequences include increased crop insurance payments and reduced agricultural revenue for farmers, creating instability that marginalizes communities dependent on agriculture. Addressing these socioeconomic consequences requires a holistic approach that considers agricultural resilience, food systems, and equitable access to nutritious food. Beyond biostimulants, other technological innovations and farming practices are crucial for mitigating climate impacts. Regenerative agriculture approaches, including cover crops, offer long-term solutions. Cover crops improve water infiltration, soil health, and control erosion. Recent research shows cover crops can mitigate flooding effects, enhancing resilience to extreme weather. Copyright African Elements.